Welcome to this YSL Microsoft Excel tutorial. In this part of the series, we're going to talk about implicit intersection with named ranges. We'll begin with a quick recap of the behavior of range names with the modern dynamic spilled array feature of Excel. We'll then compare that with the way range names used to work and show you how you can force that old-fashioned behavior by using the implicit intersection operator. Then we'll get into some examples where that's going to be a useful thing to do. We'll talk about problems you might encounter when using spilled arrays with certain functions in Excel, and also explain how you can sometimes generate circular references when you use dynamic arrays with basic arithmetic. We'll show you how you can use the implicit intersection operator to solve all those problems, and hopefully you'll have some idea by the end of why this might be a useful thing. So let's get started. To get started, I've opened a workbook containing a list of the top 20 highest grossing movies. If you'd like a copy of the same data, you can download it using the link in the video description and then follow along with the video if you'd like to. To begin with, I'd like to have a quick recap of the basic behavior of range names with the dynamic spilled array feature of Excel. And to demonstrate that, we're going to work out the profit for each film by subtracting the budget from the box office using a couple of range names. As you'll know if you've watched previous videos in the series, there are several ways to create range names. For this video, I'm going to highlight all the data in columns E and F, along with their column headers, and then head to the Formulas tab in the ribbon and choose the Create From Selection option. Once I've done that, I'm going to indicate that I want to use the top row of the selected cells to create my names, and if I click OK, I'll generate two new range names. Just to quickly reassure myself that that's happened, I'm going to highlight all the data in column E, which should now have a name in the name box in the top left-hand corner of the workbook, of budget _ M. So the two underscores there come from the replacement of two of the illegal characters for the range name, a space and a dollar symbol. I can't use either of those in a named range. I'll just quickly check that the box office range name exists as well. It looks like it does. So now that I know that they exist, I can create a basic formula in column I by saying equals, and then start typing in the name of the first range I want to reference, which is called box office. When I have that highlighted in the IntelliSense list, I can hit the tab key to insert the rest of the name, then a minus symbol, begin typing in the name of the next range, budget, and again press the tab key to insert the remainder of the name once it's highlighted. When I press enter, that single formula will generate a result for every row of the two ranges I've referred to. So the profit is calculated individually for each row of budget and box office. The standard behavior of the dynamic spilled array feature means that it didn't really matter where I chose to start my formula. If I randomly selected, say, cell J9 and said equals box office minus budget, when I press enter, I'll generate the exact same number of results and the exact same answers as the first column, this time just offset a number of rows down. It also wouldn't have mattered if my budget and box office columns didn't line up. Those columns could be offset from each other. The cell in which you first reference box office and budget simply picks the first cell of each of the two named ranges. Let's just tidy up a little bit and get rid of that second column of results. We only really need the first. So that's how named ranges behave with the modern dynamic spilled array feature of Excel. But named ranges existed in Excel way before spilled arrays were ever a thing, and the behavior of range names in those older versions of Excel was quite different to the behavior we see these days. We can actually recreate that old-fashioned behavior by using the implicit intersection operator, or an @ symbol. I'm not sure I agree with the terminology implicit intersection when we have to explicitly apply it, but that's the terminology that Microsoft have gone for, so that's what we'll stick with as well. So to make this happen, let's edit the formula in cell I2. I'm going to edit the formula using the F2 key, and then I'm going to add an @ symbol in front of each named range. When I press enter, you'll see that I end up with just one single answer, which is the answer for the top row of my budget and box office range names. If I want to get the answer for each of the other rows, I have to copy the formula down the column. The quickest way to do this is just to double-click the autofill handle to fill the formula to the height of the column to the left of it. So you'll see that the formula in each of these cells is identical. The @ operator is telling the range name to pick a value from the range that's on the same row as the formula. So that's slightly different to the behavior of the dynamic spilled arrays. If I say pick cell J9 again, and I create the same formula, equals at box office minus at budget, whereas with a dynamic spilled array, we would have got the same result using the values from the top row of those two range names. With the old-fashioned intersected range names, we get the same answer from the same row. So at this point, we're still returning information from the box office and budget range names from the same row that the formula belongs to. That has a consequence if we try to extend the copied formula beyond the edge of the cells that the range names refer to in the first place. You'll see if we go beyond row number 21 on the worksheet, we end up with value errors, because attempting to reference box office and budget on this row has no meaning. That range name doesn't exist on this row of the sheet. So there's a quick summary of the differences between budget and the two different styles of named ranges. I agree that in this particular example, it was much more clunky to do it this way, but there are reasons in Excel, even in the modern version of Excel, where implicit intersection is a useful thing to be able to do. And in the rest of the video, we'll see a few examples of that. I'd like to create some calculations which indicate whether our films meet certain criteria. So in column J, the financial hit, I want to return true if the profit of the film is at least 2 billion, or in terms of the value stored in the column, at least 2,000. Then in column K, for the critical hit, I want that to return true if the value of Oscar wins is more than 0. Let's create two new range names to help with that. I'm going to highlight the values in columns H and I, choose to create from selection from the Formulas tab in the ribbon, using the names in the top row, and then click OK to create those two new names. Then in column J, let's say equals profit greater than or equal to 2,000. When I hit enter, we'll see that that formula returns true when the value in the cell next to it is 2,000 or more. Then let's head over to column K and do the same thing for the critical hit. We'll say equals, and this time refer to the Oscar wins column, and this time check if it's greater than 0. And again, pressing enter returns true when the value of that column is greater than 0. So everything works well enough when we have just one single condition to test for. What if we wanted to combine multiple conditions in one single formula? So in column L, I want to return true if both the profit is greater than or equal to 2,000 and the Oscar wins is greater than 0. To do that, we can use the AND function. So in cell L2, I'm going to say equals and then write my first logical test as before. I'll refer to the profit field, and I'll say, is that greater than or equal to 2,000? Followed by a comma, and then I can refer to the Oscar wins column or range name and ask if that is greater than 0. When I close the round brackets and press enter, the first clue that something isn't quite right here is that we first of all return just one single result. And the second clue that something is wrong is that we get the wrong result. For this first film, Avatar, it is both a financial and a critical hit, and yet the combination of those two logical tests returns false. So this is one situation in which the way that range names are treated in modern versions of Excel isn't quite correct. What we need to do in order to make this work is to tell the AND function to treat each value of the profit range and each value of the Oscar wins range as separate individual values, i.e. we need to intersect those names. So let's edit that formula and add an at symbol in front of the profit range name and another at symbol in front of the Oscar wins range name. When we hit enter this time, we will get just one single result, but the good news is that it's the correct result. Yes, Avatar was both a financial and a critical hit. And if we fill that formula downwards, we'll get the correct result for each of the other rows. So as it turns out, there are only two films that are both a critical and a financial success. The same is true with the OR function, one of the other logical functions in Excel. If I head over to column M and say equals OR, and then say profit greater than or equal to 2,000, comma, Oscar wins greater than 0. When I close around brackets and hit enter, I'll get a single result, fortunately the correct result this time. But if I were to fill that formula downwards, I'll get the wrong result for every other row. So this is supposed to return true only when either financial or critical hit is true. And yet you can clearly see that for all the films where neither condition is true, this formula is still returning true. Once again, this is all down to the way that internally the OR function treats references to range names in modern versions of Excel. To make sure it gives us the correct result, we need to intersect these two range names by inserting an @ operator in front of each one. Having done that, I can then copy the formula down again, and this time we get the correct result for each individual film. It isn't just the and OR functions that treat range names incorrectly in modern versions of Excel, several other functions do as well. Just as another example of that, I'd like to create two new columns of calculations, one that works out the age in days of my films, and then one which somewhat contrivedly works out the age in working days, so discounting Saturdays and Sundays by default. Both those calculations are going to be based on the release date column, so let's start by creating a range name for that in the standard way. And then to work out the age in days, I've got a couple of choices. I could use the basic arithmetic of subtracting the release date from today's date, but there is also a built-in function in Excel which does the same thing. There's a function called days, whose job is to return the number of days between two dates. So if I insert the days function, I'm going to set the end date argument using the result of the today function. So that's today, open and close some round brackets. And then to set the start date, I can type in a comma and then refer to my new release date named range. If I then close a round brackets and hit enter, this one will work normally. So I get a correct result for each film. I'm not going to do the mental arithmetic here, but you can see by virtue of the fact that each answer is different, it's a pretty good clue that this is working correctly for each different release date. To work out the age in working days, there's a function called NetWorkDays. So let's head over to column O and try to use that. I'm going to say equals NetWorkDays. And then once I've inserted the formula, you'll see that again, there are two parameters that I must fill in. Or at least you could see that if the tooltip had worked correctly. Let's try that again. Let's give myself a bit more space and say equals NetWorkDays. There we go. So start date and end date are the two compulsory parameters there. So for the start date, I'm going to refer to the film's release date. And then for the end date, I'm going to use the today function again. I'll need to close two sets of round brackets and then finish the formula by pressing enter. So you can see this time, unlike the and OR functions, rather than just returning the wrong result, this formula returns an error. So in order to fix the problem again, in the NetWorkDays function, when you try to reference a range name containing a list of dates, you have to intersect that range name by adding an @ symbol in front of the range name itself. Once I hit enter at that point, I get a little message indicating that this formula is no longer compatible with earlier versions of Excel. It gives me a great suggestion. If I clicked the yes button there, it would reset my formula back to the one that doesn't work at all. It provides me with a hash value error. So I'm not going to click yes in this case, thanks Excel. I'm going to click no, so that even though it won't work with an older version of Excel, at least I get the correct answer. I can then fill that formula down the column to get an answer for each of the films in my list. So we've seen that you can encounter problems using certain functions with named ranges and dynamic spilled arrays, but you can also encounter problems even when just performing basic arithmetic in Excel. To try to demonstrate this, I've set up a very basic rudimentary cash flow system on the second worksheet here. It's the cash flow for an imaginary chocolate shop called Coco Chanel. And what we've got entered so far are basically the net income figures for 12 months. So these are just static keyed in values here. In some months we're making a loss, and then in some we're making a profit. What I'd like to do is work out the cash flow by working out the opening balance for each period, which is going to be equal to the closing balance. Work out any interest we owe on any months in which we enter our overdraft. And we're going to work that out in a separate section here called interest. And then the closing balance is going to be just the opening balance plus the interest paid plus the net income for each month. Let's start by adding that basic calculation. I want to use the range names I've already created on this worksheet to work out the closing balance for each month. So I'm going to say equals cash flow opening balance plus cash flow interest paid plus cash flow net income. So just using simple range names with dynamic spilled arrays means that entering one single formula there in column F will spill the formula across to the same width as the range names I've referenced. So at this point, because I have no other values to enter, this is just returned the same answer as the net income so far. Now let's try to work out the opening balance for each period. The opening balance is simply the closing balance from the preceding period. And I'm not going to do anything fancy here. I'm not even going to use named ranges. I'm just going to reference a cell reference. So in cell F6, I'm going to say equals E9 and enter that formula. And that's all fine. We pick up the value from column E, transfer it up to column F, and that then feeds into the closing balance for that period. Then I'm just going to try and copy that formula across. I'll just go one column because I'm immediately going to get stuck here with a message that tells me I end up with a circular reference. Now you may have encountered circular reference errors in Excel before. It essentially means that the formula in the cell is in some way referring to itself, creating a circular reference. Now normally Excel is able to indicate to you where the circular reference is by drawing arrows on the cells, showing you where the information for the cell that you're calculating comes from. But in this case, the problem is so complicated that Excel can't even show me which cells are causing the circular reference. So just to try to get some sort of insight into what's going on here, I'm actually going to approach this in a different direction. I'm going to delete those two formulae in in row number 6 first. And then I'm going to remove all of my closing balance examples. I'm just going to delete the formula in cell F9. Let's remove that. Let's go back up to cell F6 and say equals E9, and then let's fill that formula safely across that row, nice and easy. Now let's go back into cell F9 and try to create that same formula again, equals cash flow opening balance plus cash flow interest paid plus cash flow net income. Now at this point, if I press enter, I get another circular reference error. So actually the circular reference problem is in row number 9, not really row number 6. Fortunately, this time Excel is able to try to show me where the circularity is. If I click OK, we'll end up with a couple of arrows on the screen showing me that basically the value in cell F9 is trying to draw a value from cell G6, which itself is trying to draw a value from cell F9, and there's the circularity. The weird thing is, why on earth is that cell trying to pick a value from cell G6 in the first place? It certainly shouldn't be. The problem, again, is simply due to the way dynamic spilled arrays work. If I were to highlight cell F9 and then just edit the formula, you can see that the blue highlighting there, the blue color of cash flow opening balance shown across row number 6, simply referring to that dynamic spilled array in this formula is sufficient to generate the circular reference. So the solution, once again, is the same as we've seen. If we can intersect these three range names by adding an @ symbol in front of each one, we can solve this problem by referring to just one single cell of the range name for each individual formula. So you can see that that's fixed the problem for cell G6. I can then simply fill the formula across the row, and then that will cross-populate all of the opening and closing balance calculations. So let's continue and work out the rest of our cash flow system. The next step will be to work out how much interest I have to pay, if any, in any month where my opening balance is a negative number. So I'm going to assume that if I was in a negative closing balance for any period, then I pay the interest for that negative balance in the subsequent month. So what we need to do in order to make this work, we're going to separate out the calculations into this separate interest section. And I want to draw down into row number 12 any opening balance values that are less than 0. I've got a few different ways I can do that. I guess maybe an obvious way would be to use an if function. If the value of that cell was less than 0, then use the value of that cell. Otherwise, display a 0. It's a slightly more elegant approach. If we use the min function and ask for the minimum value between the opening balance and the number 0, we'll get the correct result in this row. So let's try to do that. Let's say in cell F12 equals min, and then we can refer to cash flow opening balance, followed by a comma, and then a 0. So that's the entire formula there. Now, once again, we're going to encounter a problem with this. Because of the way the min function treats named ranges, what we end up with in that cell, I would have expected to get the number 0, because the opening balance for that period is a positive number. I should have returned a 0. But what I'm in fact getting is the minimum opening balance for the entire cash flow opening balance range. In fact, if I just fill that formula across that row, I get the exact same answer for every single month. That's clearly not what I want. Guess how we can fix that problem? Once again, if we insert an at operator in front of the cash flow opening balance named range inside our min function, that will intersect that range and treat each cell individually. I get another message saying that that's not compatible with earlier versions of Excel. I don't want to set the formula to the version that doesn't work, so I'm going to click the No button to make sure I get the correct answer. And there we go, 0 for month 1. Then if I fill that formula across, I'll end up with only the negative numbers for any months where my opening balance was negative. So now we can work out the interest we have to pay in each month just by multiplying the negative balance row with the monthly interest rate. So let's do that by saying in cell F14 equals interest negative balance multiplied by interest monthly rate. When we hit enter, we get a sensible result for the months in which we have to pay interest, how much money we actually have to pay. And then the final step should be just to transfer that value back up into the cash flow section in the interest paid row, which should then cross-populate the opening balances for each of the subsequent periods. So let's try to do that. I want to reference in cell F7 equals interest paid, which is that row there, that dynamic array. I wonder if you can predict what might happen when I press enter. Oh no, another circular reference, another one of those circular references that is so complicated that Excel can't work out what on earth is going on. It can't show me where the circularity occurs. I'm going to click OK. This time the solution isn't quite as simple as before. It's not just a problem with one stage of this formula. It's actually a problem with both stages. I'm going to delete that formula I've just added to cell F7, and I'm going to go back to cell F14 and modify this. Even though it's giving me the correct result at this point, I need to modify it so that I'm referencing the interest negative balance array or range name as an intersected range name. So I'm going to put an at symbol in front of it. Once I've done that, if I press enter, I'll then need to fill the formula across to the right, which gives me, again, the same answers as I had before, just this time as single individual cells, not as a dynamic array. Now if I head back to cell F7, if I say equals interest paid, so I can still refer to my range name interest paid here. When I hit enter this time, I end up with a circular reference again, but this time I can see where the circularity is introduced. If I hit OK, this beautiful diagram of the circularity involved. So the problem is here in cell F7, interest paid. This blue arrow indicates that the value for cell F7 is being retrieved from the value of cell G14, which, of course, as we know, isn't actually the case. That's not what I'm trying to do there at all. But because I've referenced a range name, I've referred to that entire range. cell G14 is involved somehow. So cell F7 returns a value from cell G14, G14 uses a value from cell G12, G12 uses a value from cell G6, which uses a value from cell F9, which itself uses a value from cell F7, and there's the circularity. So the solution, once again, is the same as we've previously seen. If I head to cell F7 and edit the formula, I'm going to intersect that range name, hit enter, and then I can fill that formula across to the right and get the correct result for every single month. At this point, the benefits of using range names in the first place is so minimal that we might as well have just done this entire thing using cell references in the first place. And in fact, that would probably be certainly the way I would do things in the real world. Named ranges in this case just cause far more problems than they solve, I think. Anyway, at least now you have the choice. If you want to use named ranges to create something that's complicated, now you know how to fix the problems you'll encounter using the @ operator to intersect the range names and treat each cell individually. So, hope you found that one useful. Thanks very much for watching. We'll see you next time.